Well, hello there. Congratulations. If you're watching this video, you should have completed the worksheet and you're ready to check all the answers. Well, at least we hope that's how things are going, right? So, without further ado, you remember this message, which of course was brought with much fanfare and music. I'm kind of ditched the music and sped it up here a little bit. But we had no worksheet, but you were instead asked to study the trigonometry reference guide, right? There are parts of it I hope you kind of could memorize. There's other parts that's like, hey, at least you should be super duper familiar with it. So what I'm going to do is I'm going to go through, figure out the answers, and you can check your work. If you have not done the worksheet or at least spent some good time with the worksheet, it might be time to pause this video. Or after one of the questions, if you need a little bit of time, you can pause the video and then start again, and then pause it again, and start it again. But without further ado, number one. Right, piece of cake. I should go look at the unit circle and say, hey, unit circle, this is just going to be root 2 over 2. Tangent of pi over 6. Right, you should be able to consult the table that has the tangent values. And you say, aha, at pi over 6, sine divided by cosine is going to get me root 3 over 3. Uh-oh, secant. Well, if you can figure out that cosine of pi over 3 equals 1/2, you then know that the secant of pi over 3 is 2, because that's just the reciprocal. Similarly, with number 4, if you know the sine of pi over 4 is root 2 over 2, cosecant has to be the reciprocal. Of course, we would not leave it as 2 over root 2. We would simplify that as root 2. Right? So the cosecant of pi over 4 would just be root 2. Cosine of 7 pi over 4, that of course is a 45-degree angle, but it's hiding down there in quadrant 4. Right? Root 2 over 2. Right? At the 45-degree angles, sine and cosine are always the root 2 over 2. It just depends on if they're positive or negative based on the quadrant you happen to be in. Ooh, here comes a fun one, number 6. I know the sine of 3 pi over 4 is going to be negative root 2 over 2. But it's sine squared. So if I square negative root 2 over 2, it comes out as a positive 2 over 4, also known as 1/2. Similar method. If I know that the sine of 5 pi over 6 is 1/2, if I square that, I get 1/4. Cosecant is not on the unit circle, but sine is. So say, hey, sine of 4 pi over 3. Right? We're not 1 pi over 3. We're not 2 pi over 3. We are 4 pi over 3. So we are hiding in quadrant number 3. So that is going to be a negative value. Right? The pi over 3's are when we have the root 3 over 2 for sine. And because of the quadrant, it's got to come out as a negative. So the cosecant will be the reciprocal 2, whoops, so I think 2 over 2 over root 3, but of course it was negative. Wait a minute, we're not going to leave a radical denominator. So we need to rewrite that as negative 2 root 3 over 3. If I can figure out the tangent of 5 pi over 3, and of course the pi over 3's are where tangent is going to be a root 3. But I got to say, hey, what quadrant are we in? And of course, we are in quadrant number 4. So sine divided by cosine in quadrant number 4 comes out negative. So this will be a negative root 3. Ooh, but the question was not tangent. The question was cotangent. So, of course, for cotangent of 5 pi over 3, I need the reciprocal, which will get us negative 1 over root 3, better known as negative root 3 over 3. Cosine of 7 pi. Where is 7 pi, you may ask? Well, all the way around the unit circle is 2 pi. All the way around the unit circle a second time is 4 pi. All the way around the unit circle a third time is 6 pi. So for 7 pi, we've gone around the unit circle 3.5 times. So we are at the same location as pi. And so our value of the cosine of pi is negative 1. Again, at any point in time, if I'm going a little bit fast with these, pause or stop the video. Next section, right? Because this first section, you should be able to just look at the unit circle. And using the unit circle, quickly gotten these answers. Now we got to do a little bit more higher level thinking. But if you've got your reference guide, you should probably know what part of the reference guide you can look at as we try to simplify each expression. For number 11, tangent can be rewritten as sine divided by cosine. So tangent of theta is actually sine of theta divided by cosine of theta. Hey, look at that. Those cosine of thetas are going to cancel out, leave us with just sine of theta. Number 12. I see a common factor. Cosine of theta is a common factor. That will leave me cosine squared theta plus sine squared theta. And of course, this is one that we should really have memorized. This is the cornerstone of just about everything we do in trigonometry. Cosine squared theta plus sine squared theta is 1. So cosine of theta times 1, of course, is just cosine of theta. Ooh, this one looks interesting. Number 13. Well, you know secant is reciprocal of cosine. So they're going to have to multiply to be 1. Right? Because we're looking at cosine of theta times 1 over cosine of theta. So that, of course, is going to become 1. And then, of course, same deal with tangent and cotangent as their reciprocals. But it works out just a tad bit different because you're like, hey, I'm going to have tangent of theta times tangent of theta, right? Because if cotangent of theta is in the denominator, we're looking at tangent of theta. So the cosine of thetas cancel out, leaves us with a 1. And of course, tangent theta times tangent theta becomes tangent squared theta. And of course, 1 plus tangent squared theta is secant squared theta, right? You should be able to find that with the Pythagorean identities. Okay, last section, last 3 questions. Some good old basic trigonometry, right? This would take you all the way back to geometry. And of course, we all know what we need to do first when we're playing with triangles. Very first thing we ever want to do is we want to draw a right triangle. There's the 90-degree angle. We want to pick one of the angles for theta. Sine is opposite over hypotenuse, so opposite hypotenuse. For cosine, we need the adjacent over hypotenuse. Dun, 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 dun. 5 squared is 25. 13 squared is 169. So if we take 169, subtract 25, and find the square root, we are good. Right? We're subtracting because we have to find a leg, not the hypotenuse. Square root of 144 is 12. So the cosine of theta would have to be 12 over 13, right? Because the adjacent side is 12. Hey, I know, I'm going to draw a triangle. In fact, it's going to be a right triangle. I'll put theta in one of the acute angles. Tangent is opposite over adjacent. And again, a squared plus b squared equals c squared. And we'll actually add this time because we're trying to find the hypotenuse. 20 squared plus 21 squared equals c squared. 400 plus 441 is c squared. 841 is c squared. Of course, c is going to be the square root of 841, which of course is just 29. Cosecant is the reciprocal of sine. So instead of opposite over hypotenuse, I need hypotenuse over opposite. And there's our answer. Cosecant of theta would be 29 over 20. Last but not least, super duper 16. Amazing. I will draw a picture. Don't all my triangles look like beautiful, perfect triangles? Not. Cosine is adjacent over hypotenuse. And again, instead of adding, we're going to subtract because we're missing a leg. Right? If we actually want to try to set this one up, I mean, cut some stuff off. Right? If you think about the setup, a squared plus b squared equals c squared. All right? I'm going to have a 2 root 6 squared. And of course, 2 root 6 squared becomes 24. 7 squared, of course, is 49. So if I want a squared, I actually have to subtract, right? So if I want a squared, it's actually 49 subtract 24, which is 25. And so a is the square root of 25, also known as 5. Bum, bum, bum. So the sine of theta will be opposite over hypotenuse, which is 5 over 7. And there we have it. Hopefully you've had a very enjoyable day. And this should have gone quite well if you did some review of your trigonometry, which I asked you to do way back there on Thursday. So you've actually had 5 days to try to get yourself familiarized with that trigonometry reference guide. Hopefully things went well, and I will be back in the classroom tomorrow, which happens to be Wednesday. Woohoo!